All right, so we're going to do half of the notes in this video. We'll do another half of the notes later this week. So we're going to start with 2.5, and 2.5 is talking about segment addition. So that's the idea that if you have two parts of a segment, you can add them together to get the whole. We're going to start with some vocabulary, not a lot of it, but we are going to start there. So a two-column proof is a formal proof. We've worked with these, but I never gave you a formal definition. So it's a formal proof that contains statements and reasons organized in two columns. So that's what we've been doing. So then we are given another postulate here, and we will be filling out a proof builder with some of these postulates. I won't give them all to you on paper. Some of them you're just going to have to look up. But for the most part, I'll give the ones that are really important, the ones that we're going to use a lot to you. So the segment addition postulate says that if we have points A, B, and C that are collinear, so remember that just means they lie in a straight line, then B, is between A and C if and only if AB plus BC equals AC. So it basically says that if I can add these two sections together, so if I can add the first half with the second half, that is the only time that we know for sure, without a doubt, that B is in the middle someplace. It's maybe not right between them, like dead smack in the middle, but it's someplace between those 2 points. So that basically says that if I was to draw something out, and again, we don't have to have B right between. It does not have to be our midpoint. It just has to be collinear. So collinear. So now I have this segment AB. I have this segment BC. So I have these two segments. Sorry, BC, not AC. I have these two smaller segments that make up the entire segment. So if I took this entire segment and I didn't know what my length was, I could take the length of my small AB segment plus the length of my small BC segment and find the length of my whole segment. So we are going to do at least one proof with this, and then we'll move on to a little bit more information. So we want to prove that CE is congruent to EF. So if I was to draw this out, and we are going to assume these are lines, so CE is congruent to FE, so that means that they're going to connect somehow. I'm going to put F over here. So CE is congruent to EF or FE, and ED is congruent to EG. So ED is congruent to EG. Then CD is congruent to FG. So I'm saying that these two things are congruent to each other. And then finally, I'm trying to prove that CD is congruent to FG. I'm actually going to do those in two different colors. So this is what I'm trying to prove. I'm trying to prove that those two things are congruent to each other. All right, so Given that CE is congruent to my FE and ED is congruent to EG, which is what I have drawn out here for us as we went through that prove statement, then I'm trying to prove that those orange and red segments are congruent to each other. So, start out, we're going to set up our statements and our reasons. Draw those into columns. So sometimes our proofs are going to be a little bit longer, and that's okay. So I'm going to start out by stating what I have given, and I'm given these statements here. I'm given these two things. I'm not given any measurements in my picture or anything like that. I'm just given those things. So I'm told that CE is congruent to FE and ED is congruent to EG. And the reason that I can state that is because it is given to me. I can state statements like this in two different things. So if I wanted to say in statement 2 this part here and say statement 2 is also given, I can do that. If you want to save space, then you can just write it all out in one. There's a lot of different ways to write proofs. I try to conserve space. But sometimes I'll give you a worksheet that's like, nope, you're going to write out every single one individually, and that's okay. All right, so next thing, if I have lines that are congruent to each other, the definition of congruence means that the measure is equal. So I'm going to state my next statement that the measure of CE is equal to the measure of FE. And the measure of ED is equal to, the measure of EG. And I can state that because of what the definition of congruence is. So the definition of segment congruence. I'm stating specifically segments because we're working with segments. All right, so now let's think broader. So if I have these two segments, CE and ED, that make up CD. So I'm just looking at my red one right now. So if I have, I'm gonna just use a pen, let's use blue, just so you can follow along. I have the segment EC, so segment CE, and segment ED that make up the whole segment CD. So I'm going to say in my third statement that CE plus ED is equal to CD. And I can say that because of what we just learned about, which is that postulate 2.9, that segment addition postulate. And then I can do something very similar, and I'm just going to add it to statement 3 because it's going to be the same reason. I have the EG and EF is what makes up FG. So I'm going to say as well in statement 3 that GE plus EF is equal to my FG. So all I've done is I have put those two things in here and stated that this is true because of segment addition. Again, if you wanted to label this as 4 and 4 be your segment addition postulate again, you are welcome to do that. I'm going to leave it in there now that I have it written, or you could just add it to 3 and they can be both in the same statement. That's just fine. All right, so these two statements, I know that some things are true here. I know that CE, if I just look at number 3, I know that CE, I'm going to use a yellow highlighter, CE no, is equal to or congruent to FE. So I'm going to exchange that out. Let's see what happens if I exchange that out. And some of this is going to be a little bit of trial and error, so 5. I know that CE is equal to FE, so I'm going to change CE to FE. And I know that ED is the same as EG. So I'm going to change that out. And that is going to be equal to CD. That doesn't change. So I'm not told what CD is equal to. I'm trying to prove what it's equal to. So I'm just going to leave that CD alone. All right, so now if I look between 4 and 5, and the reason I can do number 5 is hopefully you're thinking it's substitution. All right, so if I look from number 4 to number 5, I've got FE or EF, and I have EG or GE, and they're the same thing to each other. And they're still adding, so I haven't changed any signs. So that means that I could state, if I was to exchange these things out, I'm told that FE is equal, I'm told that statement that I just wrote in 5, that first part, that addition part, is the same thing that's in statement 4, and that part's equal to FG. So now I'm told that FG is equal to CD. And again, I'm using substitution to do that. All right, so if those two things are equal to each other, I'm not trying to prove that they're equal, I'm trying to prove that they're congruent. But if they're equal, what does that mean about their congruency? Doesn't that mean that they are congruent if they are equal? They're kind of interchangeable terms here. So I can state in number 7 that FG is congruent to CD, and that's by definition of congruence, or segment congruence. So essentially I just use statement 2 over again, and that's okay. I can use my statements more than one time, or my reasons more than one time. I won't necessarily use my statements more than once, but my reasons I can definitely use several times. If you're somebody who's like, wait, those are backwards, that's just fine. You can change them around if you want to. This is optional. I won't dock you for it. I don't think anything will actually. But make sure that you know it just in case. I can change these around to be the same order by the law of, or the symmetric postulate. Make sure I'm right when I say that. Yep, the symmetric postulate says that I can do this. Oops. So that is by the symmetric property of equality. And I just want to move this little thing. It's not going to let me. That's fine. Okay. All right. So that's our proof. If you need to pause it to get anything written down, make sure that you are doing so. All right. So let's go to this theorem here. And we'll do one more theorem, and then I will give you what you're doing for homework. I might not give you homework. That might be nice. All right, so the theorem 2.2 is properties of segment congruence. And these are things that we've talked about before. We've talked about reflection, reflective properties, symmetric. These are kind of algebra properties that we're making into geometry properties as well. So the reflective property of congruence, that just says that if I have segment AB or any segment, and that is congruent to itself. I can say that any segment is congruent to itself. So if you want that in words, any segments is congruent to itself. For the symmetric property, if I have the segment AB, then that segment is congruent to CD. So if AB is congruent to CD, then I could also say that CD is congruent to AB. All I've done is change the order. So the symmetric property says that if any segment is congruent to another one, then you can switch the order. And finally, we have the transitive property, and my thing doesn't want to scroll. What's happening? All right, we'll write down the transitive property. Hopefully it stops being finicky. Oh. All right, so AB, segment AB is congruent to segment CD, and CD is congruent to EF. Then I can skip from point A all the way to point C. So I can say that AB is congruent to EF. And we actually did a little bit of work with this last week or 2 weeks ago. Whenever we were last in class, we actually talked about this, the fact that since these are the same, since this is the same to this, that they cancel out and we can just hop right over to our endpoint. We talked about that with the law of syllogism. It's the same idea, it's just given a more fancy name. So I'm actually going to show you why this works in proof form. So remember, proofs prove things to be true, and with a theorem, we technically have to prove these things. So why don't we prove the transitive property? So my statements and my reasons. I'm given that AB is congruent to CD, and CD is congruent to EF. And I can do that because it was given to me. Now here's the fancy thing. We can actually prove this in literally one step. So let's do it. I'm told that AB is equal to CD. Well, I'm also told that CD, and I guess if I'm going to put those in, I should put them in on all of them, but there we go. I'm told that CD is EF, and I have a CD here. So I can use substitution to exchange CD with EF, and now I have AB, is congruent to EF, and I did that with substitution. And there's a lot of other ways to do this as well, but that right there is how we prove the transitive property. All right, so I am going to post probably one problem for you to do with this. It'll be in the assignment itself. It's a little long. Don't worry about filling out this purple sheet. It's just going to be one. I'm not going to have you do two. Let's just do 1 and 4. And these are just fill in the blanks. You're going to use these definitions that we've just gone over, as well as the ones that we have talked about before. The only one that you might need to remember is you might want to go back and look at what the definition of a midpoint is, because that is something that you want. Everything else we've talked about. So just questions 1 and questions 4, and I'll see if I can even find them really fast for you. I don't think that I'm going to be able to. It's going to take me too long. So we are just going to go ahead and be done, because I don't think that I have them saved in my drive, but we can find out really fast. Hopefully I will just cut this out. Let's go to your textbook. Maybe. I thought I had your textbook saved. Here, notes, form, there it is. We want to go to chapter 2. It's probably going to take a while to load. There we go. Deductive reasoning. Lots of paragraph proofs. Chapter quiz. Algebraic proofs. And segment. Okay, so you're going to do numbers 1 and number 4. So number 1 is here, so you can pause it, write it down. You're just going to fill in those blanks. And number 4 is here. You can pause it, write it down. You're just going to fill in those blanks. And I will be checking for this on paper. So on Tuesday when I see you, you should have this done on paper.